This is the special right triangle tutorial. There are a couple special right triangles that I'd like to talk to you about. The first is the 45 degree, 45 degree, 90 degree right triangle. We call it a 45, 45, 90. As you know, every right triangle needs to have one 90 degree angle. And this particular right triangle, the rest of the interior angle degrees are divided up among two perfect 45 degree angles. A 45, 45, 90 looks like this, where you can see the left leg and the lower leg of this triangle both look like they're identical lengths. Now, an important thing to note about this triangle is that the length of the legs on a 45, 45, 90 will always be the same length, no matter what. So if one leg happens to have a length of x, the other leg is going to have a length of x. If one leg has a length of 5, the other leg will have a length of 5. And the hypotenuse is always just going to be the length of one of the legs of the 45, 45, 90 multiplied by root 2. So, if you had one leg of the triangle having a length of x, you know the other leg would have a length of x, and you know that the hypotenuse would have a length of x root 2. Now, if you knew that one leg had a length of 4, then the other leg would have a length of 4, and the hypotenuse would have a length of 4 root 2. We call it a special right triangle because it works out in such a nice way. It's a special way that works out. So, let's take a look at a practice right triangle that's a 45, 45, 90, and see if we can make this work. So off to the right here, I'll draw another right triangle. And we'll make this one a 45, 45, 90 as well. So let me just fill in the angles. You know that the lower angle is 90, so this will be 45, and this angle will be 45 degrees. So, if I were to tell you that this leg of the 45, 45, 90 had a length of 8, what would this leg's measurement be? Well, knowing from what you know of a 45, 45, 90, like the example on the left, this leg would also have a length of 8. And the hypotenuse would have a length of 8 root 2. So I'll write that in, because it's just the length of the leg multiplied by the square root of 2. Let's take a look at another example. What if I told you that the hypotenuse of this 45, 45, 90 had a length of 6 root 2? What would the two legs' length be? Well, since you know that the hypotenuse is just the length of the legs multiplied by root 2, the length of the leg must just be 6. If you were to plug these values into the Pythagorean theorem, you'd see that this is all true. If two legs of a right triangle were 6 each, then the hypotenuse would have a value of 6 root 2. Now let's try one that's a little bit odd. What if you just had a length of 8 for the hypotenuse? Well, you can see that there's no root 2 attached. And what if you knew that it was a 45, 45, 90? Well, the 8 on this right triangle, this 45, 45, 90, has an equivalent value of x root 2. So if you wanted to solve for the value of x, which would give you the legs of this triangle, so these would be x, both of them, you could take the hypotenuse 8 and set it equal to x root 2, because you know it's equal to the length of a leg, x, times root 2. So what we would do in this case to solve for x is divide both sides of the equation by root 2. The root 2's would cancel on the right-hand side, and we'd have 8 over root 2 is equal to x. But as you know, you can't have a square root on the denominator of your fraction. So, to get rid of that, I'm going to multiply this fraction by root 2 over root 2. And what you'll get is 8 times root 2 on top, so 8 root 2. And on the bottom, you'll have root 2 times root 2. Root 2 times root 2 is root 4, and the square root of 4 is 2, which is equal to x. Now you can reduce 8 over 2 to 4 over 1, or just 4. And you'll get 4 root 2 is equal to x. So here's a little time-saving device for you in the future. If you see that your hypotenuse has a nice integer value of something like 8, and you're dealing with a 45, 45, 90 like we are, to solve for the value of x, so the leg length, all you have to do is divide that hypotenuse in half and multiply that answer by root 2. So let me give you another example of this. Let's say that I told you the hypotenuse were 20. Well, if you wanted to solve for each of the legs, you could do all the work we just did. Set that 20 equal to x root 2 and solve for x. Or you could take the shortcut method. It will always work out that if you just divide that 20, that number, the hypotenuse, by 2, so it's equal to 10, and then multiply that result by root 2, that will be the length of each of your legs. They'll each, in this case, be 10 root 2. If you'd like to check my work, go ahead and do this the way we just did. Now let's move on to the other type of special right triangle, which is the 30, 60, 90. Now the 30, 60, 90 are the degrees of this special right triangle, and it typically looks like this. You can see that the leg on the left seems a little bit shorter than the lower leg. The special measurements of the legs and the hypotenuse of a 30, 60, 90 are this. The leg that is opposite the 30-degree angle has a value of x, and the leg that is opposite the 60-degree angle has a value of x root 3. The hypotenuse, which you know is always directly across from the 90-degree angle in a right triangle, has a value of 2x. So let's take a look at a practice triangle so that you understand what I mean. I'll draw this guy on the right, and we'll label it just like the previous triangle in terms of degrees. This will be our 30-degree angle, and this will be our 60-degree angle, and you can see our 90-degree angle down below. So, if I were to tell you that this side of the triangle has a value of 4, it's directly opposite the 30-degree angle, which means, according to the association we've made here on the left, this has the value of x. So you could plug that into these generic terms that we've created, x, x root 3, and 2x. So if you were to solve for this leg across from the 60-degree angle, you know that it's just the value of x, so whatever's across from the 30-degree angle, in this case 4, multiplied by the square root of 3. And if you were to solve for the hypotenuse of this special right triangle, it's always directly across from the 90, and it has a generic value of 2 times x, x being, again, the value that is the length of the side across from the 30-degree angle. So 2 times x in the case of this triangle would be 2 times 4, or 8. I encourage you to check these numbers against the Pythagorean theorem, a squared plus b squared is equal to c squared. If you plug in 4 for your a, 4 root 3 for your b, and 8 for your c value, you'll find that the a squared plus b squared is exactly equal to c squared, as it should be for any right triangle. Special right triangle 30, 60, 90 just happens to work in this fantastic little ratio like we've seen over here, with x, 2x, and x root 3. So let's try a couple more problems. What if I were to tell you that the hypotenuse of the 30, 60, 90 on the right side had a value of 12? What would the other two side lengths of this right triangle be? So if this were side length x and this were side length y, solve for x and y. Well, you know that the hypotenuse always has an associated value of 2 times x, and x being the length of the side that is directly across from the 30-degree angle. So, if we wanted to solve for x, we would just divide by 2 on both sides of the equation, and we would get 6 is equal to x, which tells us that this side has a value of 6. You also know that the leg y of this triangle, across from the 60-degree angle, has a value of whatever x is times root 3. And again, remember that x just means the length of the side across from the 30-degree angle in any 30, 60, 90. So this would just be x times root 3 for y, and x is 6, so y would be 6 times root 3. Now what if I were to give you a triangle where we gave you the length of the segment across from the 60-degree angle, and only that? Could you solve for the length of the segment across from the 30-degree angle? And could you solve for the hypotenuse? Let's give it a shot. So I'm going to tell you right now that the length of this segment is going to be 7 root 3. Well, what do you think the length of this segment over here across from the 30-degree angle will be? Since you know that 7 root 3 has an equivalent value of x root 3, you could just set this equal to x root 3. To solve for x, you could divide by root 3 on both sides. The root 3 would cancel on the left and right, and you'd have 7 is equal to x. Now we could just plug that value into the side directly opposite the 30-degree angle. And we could also plug that value in to the hypotenuse, since you know that the hypotenuse is just 2 times x. So in this case, 2 times 7, or 14. Now we'll try one more of these right triangles, these 30, 60, 90s. And in this case, I'm going to give you the length of the segment across from the 60-degree angle again. But it's going to be an integer value. It's not going to have a root 3 attached to it. So I'm going to give you a value of 9 for this side here. And I'd like you to solve for the side across from the 30-degree angle, which we'll call x, and the hypotenuse, which I'm going to call y. Well, you know that you could just set this 9 equal to x root 3, because it's directly across from the 60-degree angle. So I'll write that up top. 9 is equal to x root 3. To get x alone, we're going to divide by a root 3 on both sides of the equation. And you'll have 9 divided by root 3 is equal to x, because the root 3 will cancel on top and bottom. Now you know that you can't have a square root on the denominator of a fraction. So I'm going to multiply this fraction by root 3 over root 3 in order to get rid of that. So root 3 times 9 on top for the numerator is 9 root 3. And for the denominator, root 3 times root 3 is root 9. And the square root of 9 is 3. And that's all equal to x. Now we can reduce this fraction. 9 over 3 will reduce to 3 over 1. So we'll have 3 times the root 3 that's still there is equal to x. So now that we know that x equals 3 root 3, we can plug that into each of these generic sides. We know that the value of the leg across from the 30-degree angle has a value of x, 3 root 3. And we know that the hypotenuse across from the 90-degree angle has a value of 2 times x. And since x is 3 root 3, 2 times 3 root 3 is just 6 root 3. So we can go ahead and plug that in over here for the hypotenuse, y, 6 root 3. And now you've solved for your 3 sides to this triangle. The hypotenuse is 6 root 3. The short side, short leg, is across from the 30-degree angle, and it's 3 root 3. And we were given the longer leg with a value of 9. That's how you work with 30, 60, 90s.